So watching this video on YouTube today from Snazzy Labs called "The Problem with Self-Driving Cars," and it really made me think for a bit about people's views on self-driving cars, the basic worries, the ideas of where we're headed, especially after Tesla's autonomy days a few days ago. So that was shortly after I'd watched this other video on why Tesla won't use Lidar for self-driving cars. And this video is in response to the ideas Musk put forward in his talk at the Autonomous Days, where he was basically saying that LiDAR is a lost cause, it's expensive, and these are things that this guy mentioned in his videos too, and I'll link all these videos in the bottom of this. But basically the first thing I would like to talk about is LiDAR. So, because as in Snazzy Labs video, the basic idea of Google's Waymo, I think it's Google's Waymo, is that they use LiDAR. But if you look here, the LiDAR is only in the front. So realistically, it's going to be good for those scenarios where you're driving right up front, like you're driving forward, I mean. So in those scenarios where you're just moving forward, yeah, LiDAR is going to be helpful. But if you notice, LiDAR is so expensive, they don't put it on the back, and they don't put it on the top. So it's only in front. So it's only for those circumstances when you're driving forward. Which, if you actually look into where accidents occur everywhere. They occur when you're backing up, when you're pulling forward, when you're going to the left. You get sideswiped. So LiDAR being what it is, LiDAR as it's even as a describes it, it's basically a last stop. Basically, like. It takes care of your edge cases. It's a final check in case the image processing fails. So I like Tesla's approach to this actually more than these other companies that are putting forward a LiDAR-based approach, because it's built on the idea that you don't fail, that you don't need the safeguard. And that's very important, especially when you think about if you actually understand LiDAR. The other big problems that I haven't seen being discussed with LiDAR is it's a lot of data. It's a lot of data that you're processing, and if it's unnecessary, especially, there's no reason for it, because as Musk was describing, if he's right, they can actually do like 300 calculations per second. I think is what he was saying, which is pretty crazy high. Looking at all of these images and building a representation of the world around those images, and then running your simulation through that world that you built based on those images 300 times a second. That's quite a bit. Now, if you introduce LiDAR data into there, that's bound to decrease. You're bound to have a heavier cost, because LiDAR data is not only heavy in terms of raw storage, they're very large files typically. If you've actually worked with this data, it's heavy. Then you actually have to go through a process of converting that heavy data into something usable, which means you have to, I'm pretty sure what Waymo is doing is basically the typical LiDAR approach to making these into a 3D representation, and that's actually pretty difficult, because you have to take every point and you have to construct vertices between these points, basically, and create a three-dimensional representation that maps out basically how the software believes it should be mapped into a contiguous surface. So you just get a point cloud, basically, is what these are actually called, is a point cloud, just a cloud of points. And then the software decides how to make this cloud of points into contiguous surfaces. And that's, yet again, a heavy process. So that's the other big thing that Elon talks about, is basically they want it to be fast and they want it to be cheap. So if LiDAR is more expensive, it's adding cost, it's adding complexity. The only benefit being, if everything else fails, if the system didn't make it to level 4 autonomy by the imaging itself, then you have this, even though that's the other thing that I don't see being talked about. LiDAR doesn't bring you to level 4 autonomy by itself. So you can go to level 4 autonomy with imaging alone, but you can't do the reverse with LiDAR. You can't just take LiDAR data and go level 4, because it's not accurate enough, honestly. You can't actually distinguish what an object is by its point representation. Even if your point representations are really good, which that's the other big thing I don't see being talked about, they typically aren't perfect because they're laser based. So if you think about the things that affect lasers, reflectivity is the big one actually. Some of the work I've done is heavily laser based, and reflectivity is what messes with you. So those mirrors on your car, those shiny silver cars, it's not going to be a massive interference because the tech's actually pretty good now with lasers and this measuring, but it's not accurate. It's not fully accurate if you have anything reflective, or if the sun can interfere with this. Like basically light, if light can interfere with your light sensing technology, it's going to interfere with it. So it's still not even like LiDAR isn't 100% perfect. And there's no way really to get it 100% perfect because of the nature of what it is. It's light. It's laser based, but that's light. So yeah, that's the other big thing, is that you're adding cost for no benefit really, because you kind of get this edge case of, oh, okay, well, we can tell right at the second that there's something right in front of us, but yet again at that point it's also too late. So LiDAR really isn't the way to go. It's not going to make your car go from perfect to better, and it's not going to make a worse car go from worse to better. It's just an extra thing. It's not needed. So the other big thing, though, that I wanted to talk about that a lot of people I don't see talking about, and it's the 1 million cars that Musk wants to put out there. So why does he want to put out 1 million cars? And there's a lot of people that are basically saying that it's not possible, that he hasn't put out this many cars, so it's just not going to happen. And that's very defeatist, first of all. I mean, I think it's very possible that he could do this. He's ramped up production already, and he keeps ramping up production, so it's possible. Is it going to happen? I don't know. Is it plausible? I would say it's plausible. I would say that it's definitely something that's in his ballpark to pull off. Very difficult, but it's in his ballpark. But the big thing I was going to get to is, so if you have this image-based solution, and the big worry is, well, we need more data. That's why we have the LiDAR system. We need more data. What's a great way to get more data? If you notice, even on their boards, there's 2 chiplets. So he describes it as basically one chiplet is like your safeguard, your just-in-case chiplet, and one chiplet is your main chiplet that's actually going to be running all the time. I feel like that's actually, I don't feel like that's the entire truth. I feel like definitely if you have 2 chiplets, you should be using both chiplets. And I would imagine any engineer would be thinking similarly, because even if you have, even if you're not using the chiplet, if power is running through the chiplet, it's still getting degraded. It's not like a massive difference whether it's being used or not if power is being run through it. It's still the same way, basically. Which then means, what I'm thinking, basically, is that they are using both chiplets. That is the long-term plan. There are a lot of motherboards that are designed to use 2 chiplets. That's pretty popular in some of the work I do, too. You have 2 Xeons and 1 motherboard, perfect workstation. It's really great. And they can run asynchronously. They can run together, and they can, you don't usually run them separately, but you can run like VMs on a stack with them. So basically what I was going to get to there is, he basically says that there's always one running for your car. And there's always one running for your car, and there's another one. My belief would be that other one would be a perfect insight into gathering other cars' data as an aggregate. So you're using the data of your car, offsetting it with the data, with another source of data, and those 2 sources of data are then being combined, basically. So you're getting a perfect result from tons of data. And how do you get this extra data? That's the big issue, right? Like, honestly, if we just had cameras everywhere across all of our streets, that would fix the issue. Unfortunately, that's just not really, I mean, do we want to live in a video-based world? You start getting into those type of discussions, and I don't see that being a huge move. And it's also very expensive, though. That's the big thing. if we were to put cameras everywhere, it'd be very expensive, and you'd have people arguing about privacy, basically. But what's funny is that the whole privacy argument goes out the window with what I'm about to say next, and that is that Elon's bigger plan is to have all of these cars be those cameras. So you have a system of cameras with those cars. It solves everything. You have more, secondary, tertiary sources of information for all of the cars in your local area. So you get full level 4 autonomy, basically, because not only do you have the information of your car, but all the cars around you. And that's what I think is Elon's plan to pull into level 4, is more data. But to get more data, you need more cars. So that's why he needs to produce more cars, because that's really his only out at this point. I mean, the idea of building it again, massive amounts of video across the continental U.S. isn't really great, And even on the basis of training these systems, it's a data issue. They need more data. That's what it comes down to. These systems are neural networks. They're trained entirely off of how much they have to input. Really, it's more of like this. It really becomes more of a triangle than a rectangle. I mean, a ton of data at the bottom leads to a few specific things being looked for, which then leads to a final output. And of course, there's the last steps from that too, actually, in terms of how it's being processed. But overall, you need a ton of data, and that data never goes bad. So even if the engineers change how they're training their AI to drive, that data doesn't go anywhere. It's still there. So if they had more cars out there gathering more data, the AI would inherently be trained better. And that's very big. And that's very important, because that's even in Elon's Musk or Elon Musk talk. That's what he was making a big issue about. Is basically they don't have enough data. They don't have enough of these edge cases. I mean, training a car to drive is easy. In terms of putting it on a country road and just having it go forward and not hit the car in front of it or something like that. Those circumstances are pretty simple, and that's why I don't think that that's in any way a concern with these companies. Actually, I don't think that's they don't really need secondary, tertiary sources of information out in the country, because really the circumstances aren't as complicated. There's not multiple cars. There's not a lot of hard decisions that have to be made by a driver. That's where they're trying to get data for. And that's why these are made for taxis, which will, if you want a taxi, you probably want it in a highly congested area. And you want it in cities. You don't really want those out in the country. So they're going to get more and more data from the cities. And so they hopefully get enough. And if you want to know the answer to how to get level 4 autonomy in these cars, it's more data. Not Lidar, that's for sure. And time. Data, training, time. That's basically it. Thank you.